question for everybody. Did you guys get lightning here last night? Yeah. I know in Trenton we got a couple big bolts around like 1 a.m. What time did it happen around here? Like 3 a.m. or 3 p.m.? 3 a.m.? So 9:30-ish? All right. So we talked about lightning last time. Do you guys remember what lightning is? What's it caused by? Yeah, it's a buildup of charge, these positives and these negatives. Specifically, it's a buildup of electrons. So in case you're ever wondering how you measure what a buildup of charge is, our units are coulombs. And I'm going to spell it for you because it's a weird looking word. All right, so a coulomb is a unit of charge. Unit of charge. Where a charge is just excess electrons. All right, and one electron has a charge of negative 1.6 times 10 to the negative 19 coulomb. So a coulomb is a big unit, like a lightning bolt. That would be, a coulomb or 0.8 coulomb, right, of charge. So this is a huge unit. Therefore, an electron is a really small amount of charge. All right. Once again, it's named after a scientist. Because it's so big, you're going to find that we use a lot of abbreviations with it. We usually talk about things in microcoulombs. All right. Microcoulomb. And that just means times 10 to the negative 6. Sometimes you'll see things in millicoulomb. That means times 10 to the negative 3. I suppose you could do centicoulombs and stuff like that, in which case it would be times 10 to the negative 2. But for the most part, those are the ones that you're usually going to see. All right, so coulomb's a unit of charge. It's a very big unit. All right. Another thing that Coulomb came up with. Coulomb also came up with Coulombs Law. And what this allows us to do is determine the force between two charges. All right? So, based on that I just told you, it helps you determine the force between two charges. What do you think FE stands for? Your electric force. And what are the units of force?
Joules.
Good guess. Newtons. Okay. How about D? D is probably the next easiest one. What do you think D stands for?
Distance.
Yeah, distance. It's in meters. Now it gets trickier. What do you think Q1 stands for? Yeah, charge 1. Charge 1. What do you think Q2 stands for? Charge 2. And then K is a constant, and it's always going to be this number. 9 times 10 to the 9. So K is your Coulomb's constant. So this is really the same thing as Newton's law of universal gravitation. Just you got a different constant, you're dealing with charges now instead. All right, which means it follows the same thing. It's an inverse square. So as you pull away, it comes off. All right? Any questions about what the Coulomb is, what Coulomb's law is? All right, let me show you how it's used. So I made this problem for you. And it says a 3 microcoulomb charge is separated from a negative 7 millicoulomb charge. The force between the two charges is 5 newtons. What is the distance between them? Is the force attractive or repulsive? How many excess electrons does the negative 7 millicoulomb charge have? There's actually one more thing I got to tell you before you can even solve that. When you're solving Coulomb's law, I want to keep this in mind. Opposites attract. So if you've got one charge that's positive and you got one charge that's negative, they're going to be attracted to each other. If they're both positive, they're going to be repulsed. If they're both negative, they're going to be repulsed. So using that, we now have everything we need to be able to solve this problem. First thing we're going to do is we're going to write down the equation we'll use. So here's Coulombs law. Q1, Q2, over d squared. Okay, we know what k is. K is always the same, never changes. 9 times 10 to the 9th. Let's see, what else do you know? Yeah, charge 1 is 3 microcoulombs, which is 3 times 10 to the negative 6 coulombs. Micro means times 10 to the negative 6. What's charge 2? You got it. Negative 7 millicoulombs. 3 times 10 to the negative 3rd coulombs. All right. What was that? Oh, yeah, you're right. Thanks. Negative 7. All right, what else? You know the force between the two charges? It's 5 newtons. And they're looking for the distance. So you plug everything into here. So you would say 5 equals 9 times 10 to the 9th times 3 times 10 to the negative 6 times 7 times 10 to the negative 3rd. Now when I plugged in that 7, notice I didn't put negative 7. The reason being, eventually we're going to have to take a square root. And all these positives or negatives tell you is whether it's going to be attractive or repulsive. All right? So that's all this positive or negative in the front tells you. All right? And we can figure that out just from reading the problem. So I left it off here. If you put it in here, you get to the point where you're doing a square root and it says, you know, domain error, you can't take a square root of a negative number, just make it positive and you'll be fine. All right? So it's this over d squared. All right? Oh, actually, I forgot to bring the calculators. I'll go grab them in 1 second. Till then, somebody got a calculator I can borrow?
Yeah, there's.
Oh, thanks. So plugging this into the calculator, key this calculator. 9 times 10 to the 9th times 3 times 10 to the negative 6 times 7 times 10 to the negative 3rd. This ends up being 5 equals 189 over d squared. A lot of people get confused here. You can either put 5 over 1 and cross multiply, or you can multiply each side by d squared, canceling out the d squareds. And you get 5d squared equals 189. Divide each side by 5. D squared equals 189 divided by 5. 37.8. Then lastly, take the square root of each side. Square root. 6.15. So the distance is 6.15 meters. So there's the first time you've ever used Coulombs law. All right, it's just like universal gravitation. The next thing asks, is the force attractive or repulsive? Well, this one's negative and this one's positive. So is it attractive or repulsive? Attractive, they're opposite, you got it. And the next thing says, how many excess electrons does the negative 7 millicoulomb charge have? I like to throw this in on tests and stuff. It's actually a lot easier than you think. If you do negative 7 millicoulombs, so that's times 10 to the negative 3 coulombs, divided by the charge of an electron in coulombs, which is negative 1.6 times 10 to the negative 19. This will tell you how many electrons are in there. Divided by 1.6. It's the same kind of math as if you're trying to figure out how many dozens of eggs are in a bunch of eggs. 10 to the 16 electrons. All right, you got this many coulombs. You know this is how many coulombs it takes for one electron, so you divide the two and you'll get how many electrons. It's just like if you have 36 eggs, how many dozen eggs do you have?
3.
3. All right, you divide it by 12. Okay, and that is a Coulombs law problem in a nutshell. And that should be able to get you through what you're going to see today. Any questions? No questions? All right, thanks, Rishi. Here's your calculator back.